Today, we're tackling a problem that challenges us to construct a specific permutation based on a string of i's and d's. The goal is to build an array where each element adheres to these increase or decrease rules. It's trickier than it looks at first glance. Given a string S consisting only of I and D characters, we need to construct a permutation of numbers from 0 to the length of S. For each I in S, the corresponding element in our result array must be strictly smaller than the next. For each D, it must be strictly greater. We need to return any valid permutation that satisfies these conditions. A naive approach might involve backtracking. We could try placing each available number from 0 to n at each position, checking if it satisfies the I or D condition with the previously placed number. If it does, we recurse. If not, we backtrack. This would explore every possible permutation, leading to an extremely inefficient solution. The time complexity would be factorial, n factorial times n, and space would be n for the recursion stack and tracking used numbers. Clearly, this is not optimal for anything beyond trivial input sizes. The key insight here is a greedy one. To satisfy an I increase condition, we should use the smallest available number. To satisfy a D decrease condition, we should use the largest available number. This strategy ensures we always have the widest possible range of numbers remaining for future choices. We use two pointers, low initialized to 0 and high initialized to n, the length of the string. We iterate through the input string. If we see an I, we place the current low value into our result array and increment low. If we see a D, we place the current high value into our result array and decrement high. After iterating through the entire string, one number will be left over, either low or high, which will now be equal. We place this remaining number at the very last position of our result array. Let's trace ID with our two pointers. N is 4, so numbers are 0 to 4. Low starts at 0, high at 4. For the first character I, we put low 0 into our result and increment low to 1. Next D, we put high 4 into the result and decrement high to 3. Then another I, we put low 1 into the result and increment low to 2. Finally D, we put high 3 into the result and decrement high to 2. We've processed the entire string. Low is now 2, high is 2. The last element of our result array gets this remaining value 2. Our array is 0, 4, 1, 3, 2. The final array for ID is 0, 4, 1, 3, 2. This permutation correctly satisfies all the increase and decrease conditions specified by the input string. You'll often spot this greedy, two-pointer pattern when you need to construct a sequence or array that satisfies ordered conditions, especially when those conditions involve maximizing or minimizing values at each step. Look for problems where you're asked to build a permutation or sequence from a fixed range of numbers. This optimal solution runs in linear time, big O of n, because we iterate through the input string once. Space complexity is also linear, big O of n, for storing the result array. This two-pointer greedy approach is a classic. Try the next problem using this same pattern. Don't forget to like and subscribe for more efficient DSA solutions.